Hi guys, in today's video we are going to solve one of the easiest but one of the most important interview questions from LeetCode. That's contains duplicate. Although it's a very simple problem, but it introduces one of the most commonly used data structure, that's HashSet. So first of all we'll understand the problem, then discuss the brute force solution and see why it is not efficient, and we can finally solve it using an optimal approach with a completely dry run process. So let's get started. So the problem statement is, we are given an integer array. Our task is to determine whether any element is repeated more than once or not. Or not. So if at least one duplicate exists, then we return true. Otherwise we return false. So let's take an example. So we have an array of 1, 2, 3 and 1 as the elements. Let's name it as nums. So here if we notice 1 is repeated twice. So in this array we have a duplicate element. So the answer for this, the output for this array is true. So let's take another example, 1, 2 and 3 and 4. So here every element appears only once, so the answer becomes false. The question is simply asking, have I seen this number before? Like, just keep this sentence in mind because it will help us discover the optimal solution. So whenever you solve any interview problem, we don't have to think immediately about the hash map or hash set or any advanced data structure. Like, first think how we can solve this using a pen and paper. So if I give this array on a paper, how can we solve it? So the first intuition is we compare that element with each and every element. So this is exactly the brute force. So we compare each and every element with within the array. So for we will be iterating the array for I is equals to 0 to I is equals to n, where n is equals to length of the array, that's 4. Okay, and for j is equals to I plus 1, we'll be comparing 1 with rest of the elements. So from there to end of the elements where j is equals to n. If array of I is equals to array of j, return true, as we found one duplicate element. So the question is simple. If you ever seen a number that's repeated more than once, return true, else return false. If there is no element is repeated more than once, then we never return true. So at last we return false. So based on this, we'll just dry run this. So 1, 2, 3 and 1. First element is 1. Now we compare that with 2, which is different. We compare it with 3, which is also different. We compare it with 1. Here we found a match. So it's a duplicate. And we return true. So here the time complexity is order of n square. Why? Because every element is compared with the other elements. So 1 is compared with the n minus 1 elements. and each and every element is compared with n minus 1 elements. So n minus 1 into n minus 1, so it's equivalent to n square. Here we are not using any variable or any array to store, so the space complexity is order of 1. Space and time. Here if you observe, the time complexity is order of n square. We'll be getting time limit errors if if the array is too big. So here we need to optimize the time complexity, because in the worst case every element gets compared with almost every other element. Here in our case we got a match in the first iteration, but let's say if the array is a unique array, we'll be never getting any match. So at the end we will be iterating the array in the order of n square times. So here the solution how works. This solution works in the interview purposes, like, but eventually the interviewer will be asking an optimal solution. So can we do better than order of n square? Now let's think, what information do we need actually? We don't need the numbers related any in indices or position. We just need if any element is repeated more than once or not. So the thing is, have I seen this number before? We need to know. That's it. That's the thing. We don't need sorting, we don't need counting, we don't even need position. We only need to remember which numbers we have already seen, and that's exactly what HashSet is designed. So HashSet is a set that stores only unique values. Stores only unique values. So the property is like, whenever we try to add an existing value, we already know it has appeared before. The hash set doesn't add that, as it's already having that number. So here we initialize an empty hash set of integer. So now we traverse the array 1, 2, 3 and 1 from 0 to n. So for every number, if have you seen that number before or not? So if set already contains the number, then return true. Else, if the set doesn't contain the number which is in the current iteration, then we need to add the number. Set add the current number. So we'll take another example where the array has an elements like 7, so 2, 7, 11, 15 and again 7. Now we initialize an empty set. Yeah, so the current number is 2. Is 2 already present? No, it doesn't. So we need to add that for the first iteration, where I is equals to 0. 2 is added and I is equals to 1. 7 is added, as 7 is not present in the set, so 7 is added. And in the third iteration, I is equals to 2. 11 is added again, as 11 is not present in the set. And in the fourth iteration, I is equals to 3. 15 is also added, as it's not inside the set. So in the fifth iteration, 7 Is 7 present in the set? Yes. So we return true. The hash set tells us whether the element is already existing or not when you are pushing inside that. So this means we found a duplicate and we are returning the true immediately. So that's it. The moment we find the duplicate, we don't need to check the remaining elements. Here in this case, the 7 is at the last. There will be cases where we will be finding a duplicate element in the first half. So here the time complexity and the space complexity are, in the worst case, we will be iterating the whole array. So in this case, we have iterated all the 5 elements. So here the approximate time complexity order of 5, so it's an order of n. So and the space complexity, even for the space complexity, in the worst case, we'll be storing all the elements if there is no duplicate element. So order of n is for the space complexity too. Okay. And there can be a common interview questions too. The first one will be, why use a hash set instead of an array list? You can we can answer in the way where checking an element in the array list contains an element takes order of n, where even in the array list, under the function, where it iterates each and every element to check if that element is present or not. So while hash set provides us an order of 1 lookup, and also there is another way where we can solve this without any extra space, without even modifying an array. So the first thing is, we can sort the array. So for sorting, let's take the same example: 2, 7, 11, 15 and 7. Yeah, sort this array: 2, 7, 7, 11, 15. Now iterate the whole array and check if the 2 adjacent elements are equal or not. At some point you will eventually get 2 elements equal, and then we can return 2. However, sorting takes order of n log n. So unless the interviewer specifically restricts extra space, then the hash set is generally the preferred answer and the optimal solution. Yeah, that's the complete solution for contains duplicate. The main takeaway from this problem is not the code, it's recognizing the pattern. Like whenever a problem asks, have I seen this element before, hash set should immediately come to mind. So in the next video, we'll be discussing more about the problems regarding arrays and all the different types of data structures. Thank you for watching. I'll see you in the next one.